Hi everyone. For today's session, we learn about the antiderivative function. And the first section that is about the definition. For the symbol of antiderivative, we use a symbol is look like a curve and the function fx dx. And the meaning of this symbol that is the indefinite integral of the function fx with respect to x. In other words, that is a function whose derivative is fx. And we also use another term for antiderivative like primitive function or indefinite integral. And the meaning of this term here, that is, these are all the different way when we say a function whose derivative is fx. And then, for example, if the dx of the big fx function would be equal to small fx function, then we would say that the antiderivative of the small f function dx would be equal to big f function. In words, that is, if the derivative of the big f function is the small f function, then we would say that the indefinite integral of the small f function with respect to x would be the big f function. And for example, if we take the derivative of x squared in terms of x, it would give us 2x. Then we would say that an indefinite integral of 2x would be x squared. And in simple, that is dx of x squared would be equal to x, and the antiderivative of 2x dx would be x squared. Right? And then for now, for the next section that is about the constant c for indefinite integral. Let's have a look. Based on the previous example, we can see that x squared, that is the indefinite integral of 2x, right? But it's just one of the antiderivative of 2x because x squared plus 3 also another indefinite integral of 2x. Why is that? Because the derivative of the constant 3 is equal to 0, right? So in the general case, we would say that x squared plus c is the indefinite integral of 2x because the c here has the derivative equal 0. The c here is stand for any arbitrary constant. So we would express in the symbol that is antiderivative of 2x dx could be equal x squared plus c, where c is any arbitrary constant. And then let's keep going for the next section. That is antiderivative of polynomial function. Yeah, it's like the same with the derivative function. We also have the formula to find the antiderivative of polynomial function. Let's have a look. The antiderivative of x to the power of n dx could be equal 1 over n plus 1 times with x to the power of n plus 1 plus c, right? And this formula here is work for all real number n except the special case that is n equal -1. And then for the special case, what should we do? That is when n equal -1. That means we take the antiderivative of x to the power of -1 dx. And we already know that d dx of ln x equal 1 on x. So that's why we have the antiderivative of 1 on x would be ln x plus c. That is the solution for the special case, right? And then let's keep going with the example. For the first question, we take the antiderivative of x to the power 3 dx. And then it could be equal, just apply the formula, right? In this case, n equal 3, right? So 1 over n plus 1, right? And 3 plus 1 times with x to the power of n plus 1 is 3 plus 1. So that's why we have x to the power 4. And then plus c equal, just simplify the expression, is 1 on 4 times with x to the power 4 plus c, right? And then keep going for the second question. The antiderivative of dx over x squared, in other words, that is antiderivative of 1 on x squared dx. And in this case, because if we want to apply the formula of polynomial function, we need to put it in the correct form. And the correct form that is should be x to the power of something, right? X to the power of n. So that's why we rewrite the 1 on x squared as x to the power of -2 dx. And then in this case, n equal -2. So that's why it could be equal just apply the formula. 1 over n plus 1 is minus 2 plus 1, x to the power of minus 2 plus 1. Then don't forget to plus c at the end, and then equal, simplify the expression, minus 1 on x plus c. That should be the final answer, right? And then let's move on to the next question. Antiderivative of the square root of x dx. It could be equal, right? We also need to put it in the correct form, x to the power of something, right? X to the power of n. So we rewrite the square root of x as x to the power of a half dx, and then apply the formula. 1 over n plus 1, a half plus 1, times with x to the power of n plus 1 is a half plus 1. Then don't forget to plus c at the end. And then it could be equal, just simplify the expression, would be 2 on 3, x to the power of 3 on 2 plus c at the end. Right, and then let's keep going with the next section that is about the basic integration rule. So for the first properties, we have the antiderivative of k fx dx. In this case, we take the antiderivative of a function in terms of x. So k is just a constant. So that's why we can take k outside of the antiderivative. It's like the derivative function, right? If we take the derivative of the product of a constant with a variable x, then we can take out the constant, right? And then for the second properties, that is when we take the antiderivative of the sum of a function, right? Then we can split the antiderivative, right? It becomes the sum of antiderivative. Antiderivative of x, fx plus or minus gx dx, it would be equal antiderivative of fx dx plus or minus antiderivative of gx dx. Then let's keep going for the example. For the first question, antiderivative of minus 3x dx, right? In this case, we will use the first property from the previous slide, right? Minus 3 is just a constant, right? We can take it outside of the antiderivative. And then the indefinite integral of x, right? We already know, right? It would be x squared on 2. Just apply the formula. And then that's why we have minus 3 times with a half x squared plus c, right? And just simplify the expression. Then we get minus 3 on 2 x squared plus c, right? And then let's keep going with the second question. In this case, we will use the second rule, right? We have x cubed, 3x squared, x and 4, right? We have multiple function of polynomial, right? And then we use the second rule. We will split those terms. First, we start with the antiderivative of x cubed would be x4 on 4. Then plus the antiderivative of 3x squared, right? 3 is just a constant. So we take it outside. And antiderivative of x squared would be x3 on 3. So that's why 3 and 3 is cancelled out. And we just have x cubed, right? Keep going with plus x. The antiderivative of x would be x2 on 2, right? That's why we have a half x squared here. And then plus 4. For the antiderivative of 4, the antiderivative of 4 would be 4x, right? 4x. Why is that? Because we can imagine that is 4 times with x to the power of 0, right? X to the power of 0, the antiderivative would be x1 on 1. That's why we have 4x here. And then don't forget to plus c at the end. Let's move on to the next question. The antiderivative of x minus 1 on x dx. And then we have antiderivative of the first term, x would be x squared on 2, minus antiderivative of 1 on x, right? We already know, right, from the previous slide would be lnx, right? And then don't forget to plus c at the end, right? Let's move on to the fourth question. Antiderivative of x minus 1 on x to the power of 2 dx. What should we do in this case? That is, right, for the power of 2 on the top here, we use the formula to expand the bracket, right? We have a minus b squared, right? It could be a squared minus 2ab and then plus b squared dx. That's why we have the term here, right? X squared minus 2 plus 1 over x squared. And then we use the first rule, right? Oh, now in this case, we should use the second rule, right, from the previous slide. Then the antiderivative of x squared would be x3 on 3, right? Antiderivative of minus 2 would be minus 2x. And antiderivative of 1 on x squared would be minus 1 on x plus c. That let's recall a bit. Antiderivative of 1 on x squared would be minus 1 on x, right? And then let's keep going. For now, we will try a bit challenging question, right? Let's have a look. Antiderivative of 3 plus 5x minus 6x squared minus 7x cubed over 2x squared dx, right? A bit tricky, right? For the function here, the expression is a bit complex. What should we do? In this case, to simplify it, we just take the numerator divided by the denominator, right? So we take 3 over 2x squared. That's why we have the first fraction here. 5x over 2x squared. That's why we have 5 over 2x, right? Because x on the top and x squared at the bottom is cancelled out. And then minus 6x squared over 2x squared. X squared and x squared is cancelled out. Minus 6 over 2 would be minus 3, right? And then minus 7x cubed over 2x squared. X cubed and x squared would be x on the top and 7 on 2 dx, right? And then let's keep going. All right, for the next equal sign, right? For now, we have 1, 2, 3, 4 term, right? We have 4 term. We can split it into 4 antiderivative. And then for the first term here, we will rewrite 1 over x squared as x to the power of minus 2. And 3 on 2 is just a constant, so that's why we can take it outside. And for the second term, we just keep the 1 on x inside of the antiderivative. 5 on 2 is just a constant, so we can take it outside. And minus 3 is like minus 3 times 1, so that's why inside of the antiderivative is 1 dx and 3 is outside, right? And minus 7 on 2x, right? We take minus 7 on 2 is outside of the antiderivative, and inside of the antiderivative function it would be x, right? And then let's keep going. Antiderivative of x to the power of minus 2 dx, right? It's just minus 1 on x. Actually, it's from the previous slide, right? We have done this before. It's here. The antiderivative of 1 on x squared dx, it would be equal minus 1 on x, right? Let's keep going. That's why we have this section here. And then plus 5 on 2. We already know that antiderivative of 1 on x would be ln x, right? And then minus 3 times with antiderivative of 1 would be x. That's why we have minus 3x here. Minus 7 on 2, the constant. Antiderivative of x dx would be x squared on 2, right? And then don't forget to plus c at the end. And we just simplify the expression to get the final answer. We got for the first term that is minus 3 on 2x. The second term is stay the same, right? For the third term, it also stay the same, right? And then for the last term, 7 on 2 times with half x squared, it could be 7 on 4 x squared plus c, right? And then let's move on to the formula for simple trigonometric function, right? We have antiderivative of sine ax dx. It could be equal minus cos ax over a plus c, right? Antiderivative of cos ax dx would be equal sine ax over a plus c, right? And then for now, let's move on to the practice question. Antiderivative of sin 2x dx, what it should be. Let's go back to the formula. Sine ax, right? In this case, a would be 2, right? Would be minus cos 2x, right? Minus cos ax over a. And in this case, a is 2. That's why we have over 2. Then don't forget to plus c at the end. Right? Then let's keep going with the next example. Antiderivative of cos x on 2 dx. Right, let's go back to the formula. Cos ax dx, it could be equal sin ax over a plus c. And in this case, a would be, what should be the value of a? A would be a half, right? A would be a half. And then that's why we have sine of x on 2 is the same, right? Over a is a half, and then plus c, right? And it would be equal, because over a half, right? So we swap the fraction, it would be 2, right? Time with sine x over 2 plus c, right? And then for the last question, the antiderivative of cos 7x dx. In this case, a would be 7, right? A is the number in front of x. And then it could be, just use the formula, right? Sine ax is sine 7x over a, right? A would be 7. So that's why we have 1 on 7 sine 7x plus c. Let's move on to the next question. That is, in this case, we have the multiple function of trigonometric, right? Let's have a look. The antiderivative of 4 sine x minus 3 cos x dx. And then in this case, we have two functions, right? 4 sine x and 3 cos x. So we just split the antiderivative based on the second rule of the integration rule, right? And then for the first term, the number 4 just constant, we take it outside, so just antiderivative of sine x. And then minus 3 is just a constant, we take it outside, so antiderivative of cos x dx. And then the 4 here just stay the same. The antiderivative of sine x is minus cos, right? Plus c. Minus 3, antiderivative of cos x function, it would be sine x. And then don't forget to plus c at the end. And then just simplify the final answer. Minus 4 cos x stay the same. Minus 3 sine x is stay the same. C plus c. The constant plus the constant is also a constant. So that's why we plus c at the end. Right? And let's keep going with the next example. Antiderivative of cos x plus sine x dx. One more time. Antiderivative of cos x is sine x. Antiderivative of sine x is minus cos x and plus c at the end. Right? For the next question, antiderivative of a to the power of x minus 1 dx. Right? We have two terms, right? E to the power of x and minus 1. What is the antiderivative of e to the power of x? Right. We should know that the derivative of e to the power of x equal e to the power of x, right? So that's why the antiderivative of e to the power of x equal to itself, e to the power of x, right? So that's why the antiderivative of the first term here, e to the power of x, also e to the power of x. And the minus 1 here, antiderivative of minus 1 would be minus x, and then plus c at the end, right? And then let's move on to the last question. Antiderivative of 10 e to the power of x minus 5 sine x dx, right? For the first term here, 10 e to the power of x. 10 is just a constant, so we take it outside, it's 10. The antiderivative of e to the power of x is just stay the same, e to the power of x, right? And then for the next term, minus 5 is just a constant, right? And the antiderivative of sine x it could be minus cos x, and minus become a plus sign, so that's why we have plus 5 cos x and plus c at the end, right? And that's all for the today's session, and thanks for listening.